morning everyone. Today I am going to tackle lecture on probability and statistics, chapter number 3, basic statistics. In our introductory session, we have already seen what is the definition of the statistics, what is the main definition of the mutually exclusive and mutually exhaustive event and independent event. Okay, so in this type of the definitions and this type of the examples, we have the first example is a fair die is thrown, then find the probability of obtaining at least a 4. Okay, so before solving this question, first we write here the value of the NCR. You have already seen in the reading classes. NCR, that means the factorial n, factorial r, and factorial n minus r. This is the formula of the NCR. Factorial n, factorial r, and factorial n minus r. Okay. Next one, the main formula is if we are finding the probability of any event A or the possibility of any event A, so formula is equal to what? Formula is the total favorable event divided by the total exhaustive event. That means the total possibility, or we can say that the total possible outcomes. Got it? So always keep in mind, if you find the probability of any event A, so the probability of A is equal to what? In the numerator, we write the total favorable event, okay, and divided by the total possible outcomes, or you can say that the total exhaustive event. Total exhaustive event, that means the total probability. For example, we toss a coin. Okay, so what is the probability? The probability is that what? Getting head or tail if we toss a coin in one time. So total probability is what? Total probability is 2 for getting head or getting tail. Okay, so for example, capital A is the event for finding the probability of getting a head. Okay, so formula is what? Formula is total favorable event, okay, and divided by the total possible outcomes or total exhaustive event. So first you write in the denominator form, okay. So always keep in mind is this type of the question, first you find the total outcomes, total possibility. So if we toss a coin, so what is the total possibility? Total possibility is 2, head or tail, okay. So in the denominator we write the number 2. But in the numerator, if we are getting a head, so what is the possibility for getting a head? One possibility, so 1 by 2, okay. And if we are question given in for getting a tail, so what is the probability of tail? Only 1, so we write here 1 by 2. Same this type of the example, we throw a dice. Okay, so total the possible outcome is what? Total possible outcomes is 6 because of the dice 1, 2, 3, 4, 5, 6, 6 spaces are included. So total possible outcomes is 6. So we write in the denominator 6 number, okay, but in the numerator depends on your question. If we are getting for getting a 5, okay, so what is the possibility for getting a 5? Only 1, because of in the dice we have the 6 facets, 1, 2, 3, 4, 5, 6, and if we throw a dice and for getting a 5, so what is the probability? 5 is only one time in your dice, okay. For example, we are getting a 2, so 2 is only one time, 1 is only one time. So every time if you are getting a 2 in the dice, the possibility is what? 1 by 6. Getting 3, 1 by 6. Getting 4, 1 by 6. Because of 4 is only one time present in your dice. Okay. So here the example is a fair die is thrown, then find the probability of obtaining at least a 4. Okay. So first you find the total possible outcomes. Okay, so what is the total possible outcome? So here the solution is first here total possible outcomes. So total possible outcomes is equal to what? Total possible outcome is 1, 2, 3, 4, 5 and 6. Okay, this is your total possible outcomes. Okay, but our question is what? Question is find the probability of obtaining at least a 4. That means what? 4 is your lower limit, at least a 4. Okay, but your maximum limit is not included according to your question. So this is your set. Okay, and this is your total possibility. But according to your question, at least a 4, at least a 4, obtaining at least a 4 for get probability of at least 4. That means 4 is included, 5 is also included, and maybe 6 is also included, because of we are getting at least a 4. So here the three possibilities are maybe 4 or 5 or 6. Okay, so here first we consider the event A. A is an event. A is an event. Find the probability. Find probability of obtaining. Find the probability of obtaining at least a 4. Got it? At least a 4. That means A is equal to what? A is equal to 4, 5 or 6. Okay, so here 4, 5, 6, that means total 3 possibilities, maybe 4 or 5 or 6. So here the probability of A is equal to what? Formula is what? Total possible outcomes. Total possible outcomes. This is in your denominator form, and numerator is total favorable. Total favorable outcome. Outcome, that means the result. Total favorable outcomes. Okay. So total favorable outcomes is what? 4, 5, 6. That is total 3 possible outcomes. And the total possible outcome is what? 1, 2, 3, 4, 5, 6. Because of the diagram 6 by 6. So here 6. That means 1 by 2. So for the probability of obtaining at least a 4, so your answer is what? 3 by 6 is equal to 1 by 2. Okay. For example, in this question, for finding the probability obtained exactly 4. Listen carefully. Exactly 4. That means only 4. Okay. So formula is what? A is equal to what? Only 4. That means the one possibility are included. So according to your formula, in the denominator, you write the total possible outcomes. So what is the total possible outcomes? Total possible outcomes is 6. But total favorable outcome is what? Only 1, because of we find the exactly 4. So we write here the 1 by 6. This is your final answer. But in this question, we are finding the probability of obtaining at least a 4. So we write here the 4 by 6. So total possibility is 3. So we write here 3 by 6 is equal to 1 by 2. Okay, next question is, your next question is a bag contains 5 white balls and 10 black balls. In a bag, 5 white balls and 10 black balls are taken out at random. That means in a bag, 5 white and 10 black balls are included and taken out at randomly. So find the probability that balls drawn are black. Okay, so first you find here the total number of ball is what? The total number of ball 5 plus 10. That means 5 is white ball and 10 is black ball. Okay, so total ball is what? Total ball is 50. Okay, and here the find the probability that all balls are drawn on black color. Okay, so here a bag contains 5 white and 10 black balls at random. Here find the probability that all balls are black, and we find here the 3 balls. Okay, all black balls are taken out at random. So here 5 white and 10 black balls, 3 balls are taken out. 3 balls are taken out. So here total balls is 50 and 3 balls are taken out. That means here we write 15C3 because of we randomly selected the 3 balls in a bag. So bag contains total 15 balls. So first we solve this step. So NCR, that means factorial 15, factorial 3, factorial 15 minus 3. Got it? So open this term 15 into 14 into 13 into factorial 12. Okay, and here 3 into 2 into 1 and here factorial 12. So open the factorial. For example, you open the factorial 4. For example, so open this term. So 4 into 3 into 2 into 1. This is your answer. 4 3s are 12, 12 3s are 24. Okay, that means factorial 4 is equal to 24. Got it? So here you open this term 15C3. That means factorial 15 divided by factorial 3 into 15 minus 3, that means factorial 12. So always keep in mind there is one important point, or you can say that this is the logic for solving the factorial term. So always you read here in the denominator form. Okay, so in the denominator your value is factorial 12. Okay, so in the numerator you open your factorial according to this term. Because of you open factorial 15, so open the factorial 15. So 15 into 14 into 13 into 12 into 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 and into 1. Okay, and here you open the factorial 12. So factorial 12, 12 into 11 into 10 into 9 up to 1. So you cancel out numerator and denominator by 12 to. Okay, so this side, so this we write the factor 15, 14, 13 and factorial 12 we write it as it is because of here we cancel out the factorial 12. Okay, so here first you convert 3 5 are 15 and 2 7 are 14. So total 455. This is your total possible outcomes. Okay, but we find the 3 balls are taken out and all these 3 balls are black color. Okay, so we have the 15 balls and randomly we taken out the 3 balls. So maybe 3 balls are white color, 3 balls are black color, 1 black or 2 white or 2 black or 1 white. Okay, but we find the probability for getting 3 black balls. Got it? So obviously these 3 black balls are taken out in the 10 black balls. Are you agree with me? Okay, we have the 10 black balls and we taken out randomly the 3 balls and 3 possibility that 3 balls also are the black color. So obviously we taken out in the 10 black balls. Okay, so total possible favorable event is what? Favorable event is 10 C3 because of here 10 black balls. So 10 C3 that means what? Factorial 10, factorial 3 and factorial 10 minus 3. So that means factorial 7. Okay, so open this term 10 into 9 into 8 and here 10 minus 3 that means 7. So we write here the factorial 7. Got it? And here 3 into 2 into 1 and here we write the factorial 7. So cancel factorial 7 and here 3 3s are 9, 2 4s are 8. So total 120. Okay, that means the total exhaustive event, or we can say that the total possible outcomes is 455. But total favorable event that means we find the tan 3 black balls. Okay, so total favorable event is 120. So what is our formula? Formula is what? Total favorable event divided by the total possible outcomes, or you can say that the total exhaustive event. Okay, so here the probability of A. So A, that means what? Here we write the sentence. Here consider A is equal to, for getting a 3 black balls. Okay. So PA is equal to total favorable event is 120 and total exhaustive event is 455. Okay. So this is your final answer.